Okay, welcome back. In this video, we're going to talk about perception. Particularly, we're going to talk about depth perception, motion perception, visual illusions, and controversial topics in perception. So let's talk about depth perception first. That depth perception is how our mind perceives the distance or the depth. We're going to talk about two things here: binocular cues and monocular cues. Binocular cues are cues given by both our left and right eyes, both the eyes are binocular, and the brain then decides how far an object is based on the different kinds of information provided by these two different eyes. Then we'll talk about monocular cues, where the individual eye actually provides enough information to actually perceive the depth or the distance. Let's first talk about the binocular cues. Now, one binocular cue is called the retinal disparity. Now, if you put your finger right in front of your nose as close as possible, then close your left eye and see um, where the image falls, and you feel like it's on your right. And when you close your right eye, then you see it's on your left. Now, this different in position of the object captured by your right and left eye is like a disparity, a difference in the position of the object. And now, what the brain does is it puts together these images and estimates the actual position of the object, including its distance. Now, the way the distance comes in here is this disparity is more between the left and right images, retinal images, when the object is closer to you. But if the object is away from you, then the retinal disparity is much less. Now, depending on the disparity and how much it is, brain will determine how far an object is. Now, another binocular cue is called convergence. Convergence is the pressure that's built on your eyes when an object is at a different position from you. For example, if you're looking at an object that is too close to you, then both your eyes feel tensed. Then if you move the object away from you, there is not so much tension in your eyes. Now, depending on how tense your eyes feel, your brain will determine if the object is closer or away from you. And that's called convergence. Now, when it comes to monocular cues, information provided by a single eye is sufficient for the brain to determine the depth of the object or the distance of the object. And there are several monocular cues, and we're going to talk about each one of these. First, let's talk about the relative size. Now, for any objects that we assume to be of the same size, the object that appears bigger, we perceive it as closer. And if the object appears smaller, we perceive it as it's farther away from us. So that is a relative size. The next one is interposition. Now, when you have multiple objects and the object that you can completely see is the object that is closer to you, and the object that is obscured or covered is the one that is away from you. So when compared to the blue and the red objects here, our brain perceives that the blue is closer to you because it's complete. It's not obscured, whereas the red one is obscured. And you can apply the same thing here for the yellow and the red. Red is closer than the yellow. And this cue is called interposition. Now, the other monocular cue is relative clarity. If you can see, this part of the image looks clear, whereas this part of the image looks blurrier. So our brain perceives blurrier objects as farther apart when compared to the objects that are clearer. So that's one way of determining the depth. The next monocular cue is texture gradient. Now, if you look at it, the sunflowers here are much clearer and they have a very coarse texture. Our brain perceives that the closer objects will have more detailed texture and a better gradient when compared to the objects that are far away. And this is texture gradient cue. Another monocular cue is called linear perspective. Here, it is based on the assumption that the parallel lines, they converge as the lines move away from us. So the parallel lines, if they're farther away, they appear to be closer, and the ones that are closer to us, they appear to be apart. Now, this is how we determine the distance when you might have seen this when you drive. This is called linear perspective. Now, this is the interesting monocular cue called shadowing. Now, if you can notice, you can see several oval shapes here. And as you can see, because of the light and dark nature of the objects here, you get this a three-dimensional appearance to these objects. Some appear as dents, while others appear as bulges. And the reason for this is our brain assumes that light falls from above, And when light falls from above, the lighter parts are up and the darker parts are down. Such things will look as bulges. If it is opposite, if the lighter part is at the bottom and the darker part is at the top, then we see it as a dent. An interesting thing is these same images can be viewed differently. The dents will look as bulges and the bulges will look as dents if you turn it upside down. Well, I can't do it for you. You can pause the video. Then if you have a laptop, you can maybe turn it upside down, then you'll see that the bulges will appear as dents and the dents as bulges. Now, that was about depth perception. Now, let's move on to the next topic called motion perception. In motion perception, it is about how our brain interprets that the object in the real world is actually moving. Now, there are two kinds of cues that our brain receives that will help it determine if the object is stationary or if it's moving. Excuse me. Now, one cue is the path of the image itself. Now, what it means is that when an object is moving, the image of that object on your retina also moves across the retina. If it's here, maybe it's the image is formed here on the retina. When it moves, the image of it also moves on the retina. Now, this movement of the image across the retina, the brain will perceive this movement as the movement of the actual object in the real world. Now, this is one explanation or one way how our brain interprets movement or motion. Another perspective, another cue is through the changing size of an object. Now, if you remember when you're driving and you see some cars that are closer to you and others that are far away from you. In other words, the way you know it is closer to you is the car looks bigger if it's closer to you, and the car looks smaller if it's away from you. Now, this relative size and the change in size of the object uh, uh, will also act as a cue for the brain to determine if it's closer or away, and if it's moving or if it's becoming bigger, then it's more likely that it's coming close to you, and if it's becoming smaller, then it's more likely that it's moving away from you. Now, next we'll talk about visual illusions. Now, let's look at the first illusion called the Mueller's illusion. Now, Mueller's illusion is when it seems like the same sized lines here at the center, they appear of different lengths, right? This looks longer, larger than the one on the left. This applies, and this can also be observed in another example here, and I'm going to show you this. Yes. So before we talk about why this one here, this line looks longer or bigger than the one